Hello everyone, we're going to review for our quiz here. We're going to go through 1, 2, we're talking about discontinuities, intervals of increasing, decreasing, boundedness, and then also 1, 3 has a little bit of piecewise function stuff we're going to hit. So you're going to use Desmos to graph your functions, and then you're going to basically analyze them for me. So the first one is negative 3x to the fifth. I have the graph of the function right here, so I'm going to use this as my reference so I can go ahead and answer some of these questions. The first thing that they ask me is local minimum. So local minimum is a turnaround point and a minimum is at the bottom. So you have local minimums and local maximums. The local minimum is the turnaround point at the bottom and the local maximum is the turnaround point at the top. So the local minimum's right here, and these are gross decimals, but that's okay. It's negative 0.31 and negative 0.459. We're using Desmos. Cool. There's your local min. Local max is right here. Remember, it's a turnaround point at the top, so 0.82, 3.806. Now, these are ordered pairs, so they're in parentheses. It's not interval notation, it's just they're points. So we put points in ordered pair form with parentheses. When I do intervals, this is where you got to think, oh, am I using brackets or parentheses? So for intervals of increasing and decreasing, the most important thing that you remember is that we are only talking about x values. We're describing the x values. And if it says, where are we decreasing? As you read left to right, this function is decreasing from there to there, and then down like that. So how do we say that in interval notation? So until we get to 0.31, it's decreasing, and it's coming from the left. So the way we say from the left is negative infinity, because we are talking about x's. X's are coming from the left, and x's, when they go left, go towards negative infinity, and when they go right, they become positive infinity. So we're coming from negative infinity to negative 0.31, and we use brackets for that. That's the first interval. And the second interval, so I'll say union, is from 0.82. And then again, we're going to the right. X is getting bigger, so to positive infinity. I understand that y is going down, but I'm not describing y. I'm describing x. X goes bigger as you go to the right. So there's my interval of decreasing. Now I'll do the same thing for my interval of increasing. That's where it's increasing. So negative 0.31 to 0.82, and those are both brackets. Well, we're going to use brackets for everything except for infinity in interval notation for intervals. I have 1, 2, 3. With 2 turnaround points, you should have 3 intervals. I have 1, 2, 3 intervals, so that's good. Last question says, is this function bounded? And the answer is no, it is unbounded, and I know that because it goes up forever. There is no global maximum. It goes up forever, and it also goes down forever, so there is no global minimum, which means this is unbounded. It goes up and down forever, okay? So it's unbounded. That's your first one. Let's do another one. So you got your function there. I'm going to go ahead and hit the graph. There's my graph, nice little W shape, cool. Local minimums, same game. Those are at the bottom. So these are ordered pairs, negative 0.366 and negative 0.25. And my other one is 1.366, negative 0.25. So those are my local minimums, and my local maximum is at the top. Turnaround point, 0.5, 0.313. Again, those are ordered pairs, so everything's in parentheses. Intervals of decreasing, right there and right there. So again, we're talking about the x values. So from the left, x is coming from negative infinity until we get to this x value, which is negative 0.366, and that's a bracket. That's your first interval of decreasing, union. Here's the other one, bracket. Oh, that's not a bracket, bracket. 0.5 to 1.366, close the bracket. If you see these numbers in your interval problems, I know you don't know what you're doing. None of those numbers should be in this section because no y values are important for this, just x values. Intervals of increasing, so for the increasing intervals, it's the other two, right there and right there. So that's negative 0.366 to 0.5, brackets, union, 1.366, and x is getting bigger, so x is going to infinity. Last question says, is it bounded above? No, it goes up and down forever. It's not bounded above. Is it bounded below? Yes, it is bounded below. It is bounded below because I can draw a line that this function does not go below. It does not go below y equals negative 0.25. The smallest y value is right there. So there is a minimum to this function. That is the smallest y value anywhere, a global minimum, not just a local minimum. And this is bounded below is how we say that. There's a border, there's a boundary at the bottom of it. So it's bounded below. And that's it for that one. Let's do another one. All right, last one of these. So you got your graph. It's kind of a weird little hump thing. This little notch in there is kind of funky, but that's because it's degree 4. So let's see, local min. Well, it goes down forever. There is no local min, so we'll say none. Local max, right there, 1.385, 6.151. That's an ordered pair, local max. Intervals of decreasing. Well, it just goes down, so that's from 1.385 with a bracket. So starting here to the right, that is to positive infinity. And intervals of increasing is kind of the other game right here. So we're saying from the left, so x is negative infinity on the left until you get to 1.385, and that's a bracket. I'm not sure what happened with my 3 there. Try that again. There you go. All right, bounded. Is it bounded below? No, because it goes down forever. Is it bounded above? Yes, because I can create a boundary that it does not go above. That is bounded above. So we saw one that was unbounded, one that was bounded above, and one that was bounded below. Let's talk about discontinuities. So before you look at the graph, I would strongly encourage you to try and sort of predict what's going to happen. You should know based on the algebra what's going to happen. So I'm going to take this guy and factor the denominator. So to factor the x squared plus 7x, let's see, what multiplies to 10 and adds to 7? It'd be 5x and 2x. So I'll do the split the middle, but you guys can probably do this in your head. X plus 2, x plus 5. So those are my factors of the denominator. Okay? Get that out of the way. Whoa, what happened? You want to come along 2 parentheses? There you go. Okay. So I got the denominator factored. Now I want to know where these would equal 0 because that's how you break a function. You can't divide by 0. So I got to say, when does x plus 2 equal 0? Because that can't happen. And when does x plus 5 equal 0? Because that can't happen. And that happens at negative 2 and negative 5. If you subtract 2 on both sides, you get negative 2 or negative 5. So we have some kind of discontinuity at those 2 places. There is some issue at both of those places. We just have to decide, are they removable or infinite discontinuities? And the first thing we can look at is, can you cancel either of them out? Oh, x plus 2? Hey, look at that. Those can cancel out. So this guy is going to be a removable discontinuity. And since the x plus 5 factor did not cancel out, this is going to be an infinite discontinuity. And the one that always gets you is the removable discontinuities. If you don't know to look for them, you're not going to see them. But at x equals negative 5, I should see a vertical asymptote. So let me look at the graph and see how we did. All right. X equals negative 5. So when you sketch this, the first thing you should do is draw the vertical asymptote. Like that. And look, hey, like that's x equals negative 5. That's an infinite discontinuity. Cool. But then you're like, negative 2, like right there, that looks fine to me. What's the problem? And that's where, if you don't know to look, you're not going to see it. So let me see. That's this guy right here. So we said there's a removable discontinuity at negative 2. And if you'll notice, when I click at negative 2, it says undefined because there's a hole in the graph. We remove the factor. It's a removable discontinuity. So I'm going to put an open circle at negative 2. You need to tell me that they are removable and infinite discontinuities. I need to see them in the graph, and your algebra should back up what you're saying. Okay? So you have a removable discontinuity at x equals negative 2, and you should write that out because that's what I want you to do. You have a removable discontinuity at x equals negative 2, and you have an infinite at x equals negative 5. Discontinuity. If you don't know how to spell the word, it's up here somewhere. Discontinuity. Yeah. Okay. See one more of those. I'm going to try and factor the denominator. So let's see, what multiplies to 1 and adds to 1? 1 times 1 is 1. 1 plus 1 is 2. So I don't think that's factorable. Let's do the discriminant, the part underneath the square root, to kind of make sure that we know this thing isn't ever going to equal 0. B squared is 1 squared minus 4. A is 1 as well, and C is 1. Okay. So 1 minus 4 is negative 3. Oh, I know what's going to happen. If you do the quadratic formula, you're going to have to take the square root of that, and the square root of negative 3 is imaginary. So there are no real zeros. This denominator will never be 0 with a real number, which means I don't need to worry about it. If the denominator can't ever be 0, then you can't have a discontinuity, which means this function is probably continuous. And if you look at the graph, it is continuous. It's one of those like valley problems. So this is a good example of a problem that is bounded above and below, but it is a continuous function. There's no discontinuities in the graph. So we've seen a removable, we've seen an infinite, and now this one has no discontinuity, so it is continuous. And the last thing is piecewise functions. So you got to be careful. There's two functions here. You have f of x and g of x. One of them has the algebra, one of them has the graph. Just make sure you understand the game. F of 0, this is f, so I'm going to plug 0 in, and you need to decide which piece to use. Is 0 less than 2? Yes. So I'm going to plug it into this piece. But if you try to here, like, is 0 greater than 2? No, so we're not using that. So it's not that piece. We're using the top one. So I'll just plug it in. 0 squared plus 1 is 1. So at f of 0, you get 1. G of negative 4, that's over here. So on the graph, we're looking for negative 4, and negative 4 is right there. So you'll notice that there's an open circle and a closed circle. So we're on this jump discontinuity here, and negative 4 is on that jump discontinuity. So we're either choosing the open circle or here's the closed circle, and the question is which one wins. The answer is always the closed circle. So that says 15, so we're one above that. That means G of negative 4 is at positive 16 because you're looking right there. This order pair is negative 4, 16. When you plug in negative 4, that's where you go. You have the choice between the open circle and the closed circle, and the closed circle always wins. This is saying it's the border, but it doesn't work. Closed circle is the border, and it does work. So that's why the closed circle always wins. So that is it for your quiz review. If you can do that, you can ace this quiz. So be sure to hit that like and subscribe button, and good luck.